Hi, so this video is about being able to tell whether or not two events are statistically independent. Independent events are events where the outcome of one has no influence on the probability that the other one occurs. For example, if you toss a coin and then roll a dice, the outcomes are independent. So if I toss a coin and I tell you I got a tails, right, and then I throw a dice, the probability that I get a 3 on the dice is still 1 in 6. So the probability of getting a 3, given that I got a tails, is the same as the probability that I get a 3. They're independent events. So if we put some notation on that, if A is the event I roll a 3 on the dice, B is I get tails on the coin, the probability that I get a 3 on the dice is 1 in 6. Getting tails with the coin doesn't change this. So the probability of A given B is still 1 in 6. That means that they're independent events. They don't affect each other. An example of events that are usually not independent would be, for a Year 13 student, having a job and owning your own car. They would not be independent. And we can kind of tell that, can't we? Because we know if you're earning money, probably more likely to afford a car. In an exam, to prove that those events are statistically independent, you need to give some numbers to back that up. Not just the context, you need some numbers too. So, when we did this in our class this year, what happened was that it turned out that there were 23 people in the class that day. 10 of them owned a car. So if I pick someone at random from that class of 23, there was a 10 out of 23 or 43.5% chance that that person owned a car. Probability car, 10 out of 23. Now, in the class at the same time, there were 10 people that had a job. Okay, so out of those 10 people that had a job, half of them had cars. So 5 out of the 10 job people had cars. So the probability, if I pick someone at random that they own a car, is 43.5%. However, if I just pick from those who have jobs, that probability rises to 50%. You are more likely to have a car given that you have a job. So the fact that those two probabilities are different suggests that the events having a job and having a car are not independent. There is some link between them, which makes sense, of course, doesn't it? So here's the evidence, isn't it, for this class? The probability of having a car is influenced by the probability or by the event that you have a job. So, to sum it up, events are independent if the occurrence of one event has no influence on the probability of the other event, like the dice and the coins. Any two events, A and B, are independent if and only if the probability of A given B is the same as the probability of A. In words, event A is independent of event B if the probability of A occurring doesn't change if we know that B occurs. Not independent. If the probability of A given B is different, it means not equal to the probability of A, then events A and B are not independent. That's like having a job and having a car are not independent. Now the bottom bit's been cut off the bottom of the screen, but what it says there is event A is not independent of event B if the probability of A occurring changes if we know that event B occurs. The probability of having a car changes if I know that you have a job. So they're not independent. What you need to do now is worksheet 4 if you're at Lincoln High School, and that will give you some practice of this. See you later.